Hello and welcome everyone in this video. Today we are going to learn about the three different topics of magnetism, which is known as magnetic field, the first one, and including with this we'll learn about the magnetic field intensity also. Another we'll learn about the definition of 1 Tesla. Okay, I want to include here definition, and another we want to learn about Biot-Savar's law. Okay, it is one of the most important law, and these are the important things to be known about the magnetism. So without taking time, I would like to take you towards the definition of magnetic field. Okay, the first one. Let me read out this, and after that I'll explain each and every point what is mentioned over here. Magnetic field, it is represented by the letter B. Okay, magnetic field is represented by the letter B. It is over here. Okay, magnetic field, it is defined as a region around a magnetic material. Okay, suppose a magnet or a current carrying conductor. Okay, a current carrying conductor, suppose let me talk about the magnetic material. Okay, what type of material will be magnetic? Suppose this is a magnet. Okay, there are two poles, north pole and south pole. So from here there is the magnetic lines. Okay, several magnetic lines going from north to south pole, many, not only this much. Okay, so after that, this is a magnetic material. Okay, this is a magnet actually. Suppose this magnet has its own field, a region around a magnetic material. This is the magnetic material. The region means a space around a magnetic material or a moving charge where force of magnetism is experienced. That region is known as a magnetic field. So this region have some energy. Okay, suppose this region have some strength, have some capability. Suppose if a moving charge comes in this region, then this region exerts a force in this moving charge. Okay, this thing I have already talked in the video of Lorentz force. You can click that video in the upper I button or down in the description. Okay, Lorentz force, I have already explained about this. So another magnetic material I would like to talk about, the current carrying conductor. Suppose in this wire a current is flowing from down to up, then what happens? It creates a magnetic field. I have already discussed about this in the right hand thumb rule. Okay, this thumb will indicate the current carrying direction, and this finger will give the direction of magnetic field. Suppose this finger is coming up from down, so magnetic field direction will be here. Okay, down to up. If current is going up, magnetic field will be in this direction of finger, down to up, and in this way. Okay, down to up. It means if this wire is going down, then I need to change it like here. Okay, current in opposite direction, then magnetic field down to up. If current in down direction, then magnetic field will be, suppose here, down to up, and here if the current direction is opposite, then it is also down to up, but the direction is opposite. Let me explain you in this one. Okay, this is a current carrying conductor. Suppose the current is moving in this direction. If a current is moving in this direction, I'll place my thumb over here. Current magnetic field will be from here to here. Okay, the direction will be from here to here. Here the direction of magnetic field is from north to south, and in this case magnetic field direction is from here, and in the other case the magnetic field direction will be changed. You can try this by yourself, okay, by using a right hand thumb rule. I'll give the link of that video in the upper I button also. So this one is a magnetic field. Okay, it creates a field, and it has some value of that field that is represented by the letter B. Okay, and what is the SI unit of those value of a field? That is a Tesla. Okay, Tesla. SI unit of magnetic field is Tesla, and the CGS unit of magnetic field is Gauss. Like SI unit of, okay, SI unit of magnetic field is Tesla, and the CGS unit of magnetic field is Gauss. Okay. Mm. Here I was talking about magnetic material because if a moving charge or a moving charge, okay, if a charge moves in the current carrying conductor, then it creates a field. And same thing, if the field is created, you can imagine by this way. Suppose if the field is there, magnetic field, current produce magnetism, it have a field, so it have some value of magnetic field which is represented in Tesla, and Gauss will define 1 Tesla later when the time comes. Now let me define U as a SI unit is 1 Tesla. 1 Tesla is equal to 10 to the power 4 Gauss. Now what do you mean by magnetic field intensity? This one is magnetic field intensity. The magnetic field strength in any point of magnetic field. Suppose this is a magnetic field. This is a magnetic field. Suppose I want to find a magnetic field value over here. Okay. What is the value of magnetic field over here? That is given by the magnetic field intensity. Suppose near a magnet, the magnetic field value will be more. The strength of this magnetic field will be more near. If we go far, the strength will be less. That value, that strength value, the power calculation, okay, of this magnetic field is known as a magnetic field intensity. I'll define it as in this way. Magnetic field is strength in any point of magnetic field. Suppose in any point, here, wherever you like. Suppose here, what is the strength of this magnetic field? That is given by the magnetic field intensity. I hope it is clear. Now another one is 1 Tesla. Okay, 1 Tesla. Okay, I want to read out the things mentioned over here. Okay, what is 1 Tesla? Tesla means the value of SI unit of magnetic field is Tesla. Okay, I have already talked about this, and this one is a CGS unit is Gauss. Suppose SI unit of length is meter and CGS unit is centimeter. Okay, the relation between Tesla and Gauss is 1 Tesla is equal to 10 to the power 4 Gauss. Suppose 1 meter is equal to how many centimeter? 100 centimeter. You can relate by this way. 10 to the power 4 means after 1 there are 4 zeros. Suppose 1 Tesla means this much Gauss. 10,000 Gauss. Okay. Now, if a magnetic field exerts 1 Newton force in a 1 coulomb charge moving with the velocity of 1 meter per second perpendicular to the magnetic field is called 1 Tesla. It is mentioned over here. Okay. This one is 1 Tesla. So what does it mean? Okay. I don't want to go with this definition, but before that, we are familiar with the Lorentz force. I have already explained about the Lorentz force. The video link will be given in upper I button. Okay, you can click over there, and later on in the description also you can click. Okay, and later on you can view this 1 Tesla later. But right now I want to go through this 1 Newton force in this scenario. Okay, F is equal to Q E plus P cross B. Suppose here, if you have already seen this video, this E is, okay, this actually Lorentz force means the force exerted on the charged particle Q if it is kept in the electric field E and magnetic field B. But here we are talking about only about magnetic field, so we will not take about this E. Okay, so what we will take? F is equal to Q B cross B. Then what is the value of B cross B? Q B B sine theta. Okay, this is the force. Actually this is the magnetic force. Okay, the force which is given by a magnetic field if a charged particle comes in this magnetic field. Okay, at what direction it comes? If it comes parallelly, then it do not create any kind of field. Okay, any kind of force. Suppose this is a magnetic field. Okay, if a charge comes parallelly, okay, suppose magnetic field is also in this direction. Suppose if a charge comes in this direction parallelly, then it do not gives any kind of field force to the magnetic field. But suppose if the magnetic field is in this direction, if a charge goes in the perpendicular direction, okay, of magnetic field making 90 degree, then it experience a force. This I have clearly mentioned in the video of Lorentz force. Okay, you can click over there. What happens if a charged particle comes in magnetic field? It experience a force. Okay, I don't want to go deeply. Okay, it experience a force. That force can be defined as 1 Tesla. What type of force is called 1 Tesla? Okay, by this formula. Suppose here is B. Okay, this formula I will write here. F is equal to Q B B sine theta. If you bring B over here, F by Q B sine theta. I am taking the other term on the other side. Suppose if the value of B is 1 in SI unit, that is 1 Tesla. What is the value of force in SI unit? 1 Newton. What is the value of charge in SI unit? 1 coulomb. What is the value of velocity in SI unit? 1 meter per second. Suppose 1 Tesla is such a magnetic field, okay, like this, okay. 1 Tesla is such a magnetic field which gives the force of 1 Newton to 1 coulomb charge. Suppose if a 1 coulomb charge comes here, then this magnetic field this magnetic field exerts a force of 1 Newton on that 1 coulomb charge. And not only this much, the 1 coulomb charge should move with the velocity of 1 meter per second also. It should move in the velocity of 1 meter per second and not parallelly but perpendicularly. Because if there is parallelly, then what happens? What is the value of sine 0? Sine 0 means theta is, if the theta is 0, suppose if the angle between magnetic field, okay, if the angle between magnetic field and suppose this is the magnetic field, these are the lines represented by magnetic field, and if the charged particle moves in the same direction, that means angle is how much? If the both lines are parallel, then the angle is 0 degree. If angle is 0 degree, sine theta will be, sine 0 degree will be 0. If any number is divided by 0, the value will be infinity. We will not get 1 Tesla. But if the sine theta value is, if the value of theta is 90 degree, then what even this term will be equal to 1. So whatever 1 Newton divided by 1 coulomb divided by 1 meter per second will be equal to 1 Tesla. So I want to go through this right now. If a magnetic field exerts 1 Newton force on a 1 coulomb charge moving with the velocity of 1 meter per second perpendicular to the magnetic field, then such type of force is called a such type of magnetic field is known as a 1 Tesla. Okay, I hope it is clear up to here. So after this, I would like to move towards the Biot-Savart's law. What is Biot-Savart law? Okay, we'll learn about this in this video. Okay, Biot-Savart law. We'll see about this 1 number point. Magnetic field due to a current carrying conductor at a distant point is inversely proportional to the square of the distance between them. Suppose if this is a current carrying conductor, okay, if the current is there, it creates a magnetic field. Okay, this direction can be predicted by the right hand thumb rule. Okay, then what even if any point I want to wish the magnetic field to be found in this point. Okay, magnetic field due to a current carrying conductor at a distant point is inversely proportional to the square of the distance between them. Suppose this distance is r, then what happen? Magnetic field, okay, B will be inversely proportional to r square. Suppose if r increase, then the magnetic field decrease. Suppose if the point is taken in far distance, then r increase, then the magnetic field at far distance is low, magnetic field decrease. If the point is taken near, then the value of r decrease and the value of B increase. So by this way, it is the relation which is given by this number 1 point, and the 2 number 1 is magnetic field is directly proportional to length of conductor and current carrying through it. Suppose length of conductor means this conductor length. I can represent it as a length L. Okay, and the current carrying through the conductor is I. If more current flows, then more, suppose I want to write here relation IL. Okay, if more current flows in this conductor, more magnetic field it creates, B. If more the length of conductor, then more magnetic field it creates. Now what happens if we combine these two relation? Okay, If we combine these two relation, we get B is equal to I L by R square. Actually, this I L can be written as a I directly proportional, okay, I dl sine theta by R square. This sine theta, I am already talking about this. If if the theta is 0 degree, okay, then the value of magnetic field will be 0. Okay, I have already talked about this in Lorentz force. I am repeating once again. Please have a look on that video. Link will be in upper eye and in the description. Okay, and if we remove this proportionality sign, then it will be represented by a constant. Okay, the constant will be mu naught by 4 pi I dl sine theta by R square. If you neglect this, you can see the relation between B and R square is up and down. In between there is equals to. That means if R increase, B decrease. If I increase, B increase. If DL increase, B increase. This is the Biot-Savart's law. It is very simple. Yes or no? Please write in the comment section. And how is my teaching? Okay, you can give a feedback in the comment section also. Okay, today we have learned about magnetic field and magnetic field intensity and definition of 1 Tesla and Biot-Savart's law. If you like this video, then hit a like button, okay, and please share it to your nearby friends. And if you want to join, if you want this type of content, okay, then you can please join my channel. We'll meet again. Bye bye.